Remember the pond I talked about last time that makes water filtration system biological this time around. Now, the job is done already, but we now need to do what I call this video, like a manual video. That's what I call this. Now, I'll take it around to see exactly what has been done so that it will be easy for maintenance of the system. That's the aim of this video. Now, let's look at it. The water looks really green now, but the water coming out from the pond, let somebody just take the water now. Remember when we were doing the work, the pond was lowered and there was no fish in there. The elements, the algae, will definitely come right in to create a home inside there. And then eventually, by the time water was now placed in, the algae is now floating. But I can assure you, in about 3-4 days, this algae is gone. In fact, evident from the water coming from the filtration unit. Now, you have to take water from the outlet. Let's see. You will find that the water coming out is crystal clear. All right. If you look at the water is clean, absolutely clean. I wish we have more transparent stuff, but if you look at it against the sun, you can see this is clean water. And that's what's going to happen in a few days to come. So what exactly will make this happen? Now we have two options. Either we lower this water and then do a mop-up of the floor to really help to make the water to be crystal clear fast, or we hold on for about 3-4 days. After all, what every fish wants is not a crystal clear environment, and we don't have that in nature. What they want is clean, clear water. The bottom can be probably filled with algae, with mud, but the water must be crystal clear. After all, fish need the algae, a bit of the crusted algae to eat as vegetable, isn't it? And if it was a catfish-oriented type of fish that we put here, they will need some of the mud. In fact, koi's and goldfish, they call goldfish Chinese pigs of the river. So they are always eating. If you check their stomach, like biology students will do in the university, you'll see that half of the contents in the stomach of goldfish, sapronid family, half of the content in their stomach is always detritus. Detritus talks about, it's not sand, it's not twigs, it's not detritus, just, muck. Muck, the raw poly area. That's what you say inside the stomach. So what's the big deal about trying to make the water to remedy this green go up? The green will go off on its own. Why? Because we already have UV light, activated carbon already in the system. So it's just a question of a few days. But if the owner decides that we should go ahead, remove the old water and clean it and make it look crystal, it's okay. But I don't think you should be very happy about that. That's how I'm concerned. So I'm going to get back to the real functionality of the biological filtration system after this time. Now to the functionality of the water garden that is being operated with an inverse flow multi-chambered biofiltration system assembled by Mr. Fish and his team right in here. The first thing first is the high volume, low pressure submersible pump that is installed in here, that is pushing water that already has urine, excrement, waste food, algae, and even contaminants. The water is pushed through a pipe, this pipe, right, and straight on. It comes like that on the wall, straight on. It goes on straight like that into these 4 chambers. So we're starting with the first chamber right here. The first chamber right here. Now the first chamber here is called sedimentation chamber. Sedimentation chamber, as the word implies, to sediment solid waste. Though the main problem we'll have is the liquid waste. So first of all, to be able to take care of the liquid waste, the urine of the fish, right, and all the chemical waste or biological waste that's miscible in water, we will first of all need to make sure that the solids will not disrupt the guys that are going to do the work, which are called beneficial bacteria. I'll tell you names a little bit after this. So here we have pipes that will actually make the water to sediment. The water moves slowly in between like that, pump, 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 through what they call ricocheting. Remember the word ricocheting? If you mistakenly shoot a bullet against the wall, you might end up killing yourself. If the wall is strong enough, the bullet can just bounce back at your face. They call that ricocheting. So, but that's a negative one. But the positive aspect of ricocheting is what we're using. The water bounces all across, and then before it comes up. So it takes almost about 15 minutes, 15 to 30 minutes to really get up into the stuff here. And right on top here, we now have what we call BioD, right? This is a biofilm, but I named BioD after the first name of my wife. I think I got it right. Now, what does this do? This actually do a little bit of biological filtration. This does a little bit of biological filtration. It does a little bit of biological filtration. Why does it do it? Because 30% of filtration comes from the sedimentation chamber. Then straight away we move into the nitrification chamber. Here, we're going to wash all of this later on. Now we have media that's going to hold the beneficial bacteria, Nitrosomonas and Nitrobacter. Nitrosomonas and Nitrobacter are the ones who will do the job. Nitrosomonas turn the urine and a little bit of liquid poo into nitrite. Why Nitrobacter turns Nitrosomonas turns the the urine into nitrite, while Nitrobacter turns the nitrite into nitrate. And nitrate is what you see when you say NPK fertilizer. Nitrate is what makes the leaves of plants green, right? So it's liquid fertilizer. So if you want to even wet this beautiful garden here, what they need to do is just to take the backflow water here and they got to reach fertilizer to wet the plants. So we've got two chambers, bacterial chambers here. Why two? Because to make the system take the full capacity coils that will be here, Japanese coil, you will need a system that is not less than 1/5 of the surface area of the area that it's going to work on. So that's why we have to make sure we have access to two. I hope that's clear. Then from there, the water goes into the last chamber. I call it ion exchange chamber. Now here we got three things on the layers. We've got, first of all, seashells. Then we got clinotilolites, and then we got some carbon. Before we now have some shells again in there. Why? The net result of metabolic functioning of a fish when it digests food is acidity. But the acid is going to affect the fish later on because it begins to leach their bones. And when bones are leached because of the acid water, the fish will not be able to grow big, and which is not good enough for the fish. They want a koi that will grow to 2 meters, that can live for about 20, 30, 40, 50, even up to 70 years. So we've made room for that. The shells actually neutralizes the acidity. And then we got carbon in there. Carbon is to actually make the water crystal clear and to remove odor or smell that we'll have in there. Activated carbon, not charcoal in there, that you see that you have from firewood. No. For beery, people used to use this a lot. Now, because of the surface that they have. Then finally, the clinotilolite. They call them ion exchange resin, but we have the natural one here. They only need to be changed in 2 years' time. What they do is that in case a young child comes in here, because it is a place where people have fun, nail can drop in, spectacles can drop in, small oil can drop in and go. These things are harmful to fish. They can over time contaminate the water and start seeing fish mortality. So what we do is to put that there so that the water coming, anything metallic at all that comes into the pond, by the time it passes through the clinotilolite, it's already neutralized. Bam. And then finally, we have this. We call it the LED device, longitudinal electromagnetic device. What it does is to energize the water back, because water is coming from their filtration system in the home here, and I'm sure it could be reverse osmosis, who knows now, but whichever way is dead water. Now what the coils will like, because they're found in the mountains in China, Japan, high mountains with natural spring water. So what we did was to put this there so that I can revert the water back to the original, which is not H2O, but H74037. Then finally, after this, so this one energizes, not only bring the water to superior quality, but it boosts the immune system of the fish so that they don't even get sick at all, and help them to digest the food as quickly as possible. Then finally, before the water flows back into the system, we're going to install this guy in there. Boom, boom, boom. The UV light. It's going to be installed somewhere here. What the UV does, since there's no shade for now, and the sunlight is a little bit harsh here, right? Because this is next to the beach. So we want to be sure that and dry season like that, you still see a lot of algae, spores going. So what this one does is to actually kill algae. That's the first job. And then of course remove any germs that's inside the water that's escaped the biofiltration. Can you point to the biofiltration system? That's escaped the biofiltration system. So the UV light is going to be here, foam installed, and then clean water comes back, and the fish is just excited and happy. Happy koi, happy customer, happy meditation, happy fun. So this garden pond complements the garden, and I hope it's going to be the best thing that's ever happened to this garden. Okay, there are some other things that needs to be done, but then the basic denominator is to make sure that the water is perfectly okay, that doesn't need little or no maintenance over a period of 6 months, and that's what we have achieved. Thank you so much for listening, and I hope this will serve as a nice working manual for now.